For our physics project, we wanted to look at how the path of light rays is affected based on different factors. Our motivation for this project is based on how light affects the things that we see on an everyday basis. Light direction can be changed when it encounters an object such as a mirror, but continues in a straight line or as a ray. Ray is defined as a straight line that originates at some point and comes from mathematics. There are 3 different ways in which nature can travel from a source to another location. One way is light coming from a direct source through empty space. An example of that would be the sun's light traveling thousands of miles towards the earth. In addition, light can also travel through different media such as air and glass to a person. Lastly, light can travel using a reflection through a mirror. The later part is what our group is testing in this project. In nature, the sun gives off light rays in which the eye refracts the light using the cornea, the clear curved part of the eye. The amount of refracted light is then controlled by the pupil, the dark opening in the center of the eye. There are different parts of the eye that allow us to see the wavelength of the light that enters the eye, as well as allows us to see different objects that are different lengths and create an image clearly. But we will only be focusing on how light travels based on its source, placement, and obstruction of path. Due to the restrictions in place, each member that was in charge of the experiment was given a different light source to use: an uncovered light bulb, a flashlight, or a laser. First, we observed what happened when an object is in the path of a light source. We noticed when placing a notebook in front of the light source that it would create a shadow which stopped all light rays from hitting the mirror, but the smaller the shadow is, the more likely a light ray will hit the mirror at a greater angle. For the uncovered light bulb, it was set 0.5 meters above and 1 meter away from the mirror, which is 1 meter in length. The flashlight and laser were taped to the ceiling 1.5 meters away and 1.135 meters above the mirror, which was 1.5 meters in length. Using the law of reflection, both the angle of reflection and the length of the light streak was found for all light sources. The law of reflection states that 1. The incident ray and the reflected ray are both in the plane, which is perpendicular to the surface, and 2. The angle of reflection equals the angle of incidence. First, we needed to find the angle that the light was when hitting the mirror, which would then help how long the light streak was using the angle and the length of the mirror. For the lamp, the angle was 26.6 degrees and the length of the light streak was 2 meters. For the flashlight and laser, the angle was 37.11 degrees and the length of the light streak was 1.98 meters. In order to explore this concept further, we looked to find a correlation with the angle of the light ray hitting a reflective surface and the length of light streak. Using multiple angles, the correlation found was the bigger the angle of reflection and the smaller the mirror length, the smaller the length of the light streak is. The opposite being the smaller angle of reflection and larger the mirror length, the larger the length of the light streak is. In conclusion, the angle of where the light ray is hitting a reflective surface with its length does affect the length of the light bouncing off the surface.